Hello everyone, welcome back to another video lecture. In this video lecture, we are going to cover the concept of shear force and bending moment. Concept of shear force and bending moment. Right? So first we'll see the shear force. So what is shear force? We know that shear stress. Now we are going to learn in second unit, that is shear force. So how you define shear force and what it is? So shear force at any cross section of a beam or a section of a beam let's assume a beam, the span AB, right? So shear force is at any section of a beam is equals to the algebraic sum of all the forces. Let's say this is a section, let's say XX is a section, let's say another section is YY. So what is the algebraic sum of forces at this particular point? Either from left direction or either from right direction, right? So I will try to define here. At any section of a beam is equals to the sum of algebraic sum of all the forces, right? Either from left or either from right or to the right of the section. So shear force at any section of a beam is equals to the algebraic sum of all the forces, either left or to the right of the section. So this is our beam. So if I want to calculate the shear force at this section, we can take from left or right, and this is the algebraic sum of all the forces. So shear force is denoted by capital F, right? And the units for shear force is SI units, that is kilonewton, right? So I will try to define with another definition, that is the shear force at any cross section of a beam may also define as the unbalanced vertical forces to the left or right. Okay, very simple. Defined as unbalanced vertical forces to the left or right of the section, right of the section. So it's easy to define, right? So unbalanced vertical forces. So these are vertical forces acting on the beam at any cross section. If you take this cross section XX, so this is the total amount of forces acting from left or right. So we'll see the sign convention. Sign convention for shear force. So please concentrate, it is a tricky part. most of the students get confused here. So how to take sign convention, whether take positive or negative. So if the arrow, that means the force at the support, is showing upward direction, right, we'll take it as positive shear force, that is upward direction. I will write upward, right? So in your, for example, how to remember this, for just to remember, for the sake of to memorize this, in our career we have to be upgraded every time. We have to improve our skills, we have to improve the communication skills, we have to improve all the technical skills. So always be positive and your life will grow. So next we have a downward direction. So we take it as negative shear force. Downward direction, okay? So for this we take positive, for this for negative. For example, let us consider a beam AB is supported, have a support reaction here, here and here. So let us say 50, 40, 40. For the calculating the shear force, we take this as negative because it is indicating downward direction, right? For this too we take positive because it is upward direction, right? So downward is negative, and if it is, the arrow is upward, then it is positive, right? Bending moment. So how you define bending moment? The bending moment at any cross section or any section of a beam, let's say AB. So how you define the bending moment? So bending moment at any cross section, any section of a beam is defined as the algebraic sum of moments of all the loads. So in shear force, it is defined as the algebraic sum of forces. In bending moment, it is the algebraic sum of moments at all the loads, right? So the bending moment at any cross section of the beam is defined as algebraic sum of moments of all the loads. Defined as algebraic sum of moments at the load, it's of the loads about the section. By considering the either from left or right. By considering either from left or right of the section, right? So I will repeat it. The bending moment at any section of a beam is defined as the algebraic sum of moments of the load. So bending moment is nothing but the perpendicular load multiplied by perpendicular direction, right? The load about the section by considering either from left or from right. Okay, if you take movement from A, will come from the right direction. If you consider B, will come from left direction. So shear bending moment, it is denoted by capital M, and the units for this in SI units, that is kilonewton meter. Okay, so this is all about the definition of shear force and bending moment. So now we'll see the sign convention for bending moment. So now the interesting part of bending moment, sign convention. So how you take sign convention for bending moment, right? So we have sagging or positive, we call it as sagging or positive bending moment. Bending moment. We'll understand what is sagging bending moment, and we'll also find out a trick, a easy trick. I will say you easy trick to remember the sign convention. So it is looks like this. If the movement of a beam will have a sagging shape, so here is a moment, here is the moment. So this we take it as positive bending moment. For shortcut I write BM. So positive bending moment. So from, let's say this is A, B. From A it is clockwise direction, right? Clockwise movement. From B it is anti-clockwise movement. Right? So to remember, there is an easy trick. Sagging, let's remember sag, that is S stands for sagging, S stands for smile. So if the beam looks like a smiling object, we take it as a positive. So in our life, we have to be always keep smiling. So that is how you can remember. So next we have hogging. Hogging or negative bending moment. Right? So here, in negative bending moment, the beam will have a movement in this direction. This kind of movement is called hogging or negative bending moment. To support this, there will be a movement at A, that is anti-clockwise, and at B it is clockwise. So it looks like a sad smile, right? So we take it as negative bending moment, right? So now you can see the difference between sagging and hogging bending moment. So to support this beam, there will be anti-clockwise from point A clockwise movement, anti-clockwise movement, and clockwise movement, right? So this is how we can take this kind of sign convention when we are doing problems, but we have a procedure to follow when we are trying to find out the shear force and bending moment. So we'll see step by step and understand each process or procedure to find out shear force and bending moment. Yeah. Procedure to be followed for shear force and bending moment. Bending moment. Right? Bending moment diagram. Procedure to follow for shear force and then bending moment diagram. Right? The first point to be considered, that considered the left or right side of portion of a section. Let's suppose this is a beam. Considered left or right side of a section. So let's say this is a beam. So if I try to draw shear force or bending moment, I have to first step is consider whether I have to go from left or from right. So that is considered the left or the right portion of the section. Right? That is the first point. Second point, the position of value of shear force and bending moment are plotted over the baseline. So we have to plot shear force and bending moment over a baseline and negative values below the baseline. For suppose we'll draw a baseline. For the positive value we show above the baseline. For negative value we show below the baseline. Right? The second point is the positive values are of shear force and bending moment we show above the baseline. The positive values will show above the baseline. Let's say this is our baseline and we show the positive values above the baseline and negative values below the baseline. So that's what is the second procedure. That is, the positive values of shear force and bending moment are plotted above the baseline. Right? And negative below the baseline. Right? So this is the second step. Third step is to find the reaction of the supports. Let us find the reaction, find reaction support, reaction of the support and draw line below the load, below the loading, below the loading point. So you can, once we try to draw, take a problem for shear force and bending moment diagram, you can clearly understand each and every step. The shear force diagram, shear force diagram will be increase or decrease, will be increase or decrease suddenly. Okay, the shear force diagram will increase or decrease suddenly by a vertical straight line, right? So shear force diagram will be basically with like for suppose it is vertically up or vertically down, so it looks like this. This is positive and this is negative, right? So first step is to consider left or right of the section. Next, positive values will be drawn above the or plotted above the baseline, and negative value will be below the baseline, and find the reaction supports and draw the line below the loading point. Then shear force will be always increase or decrease suddenly, or it will be linear at a particular straight line. So next point we'll see, that is shear force. So for shortcut I am writing SF, that is shear force between any 2 points, any 2 vertical load will be constant. Shear force between any 2 vertical loads will be constant, and hence shear force diagram between 2 vertical loads will be horizontal, right? Here the shear force between any 2 vertical loads will be constant. So you have to remember, shear force between any 2 vertical loads will be constant. For example, so here is a beam, okay, so it having a support reactions and a load acting middle of the span. The shear force diagram will be constant. So this is positive and this is negative, and this will be W by 2. If it is W, it will be W by 2 and it will be W by 2. So this is our baseline, and the positive value we drawn on the top of this baseline, and the negative value will be below the baseline. So I will write here, so baseline, and this is the length L, and this will be L by 2, right? This half of the length will be L by 2, the total length will be L. So this is the shear force diagram, right? So here the shear force between any two vertical loads will be constant. The next point will be, if there is no load between 2 points, so what happened to the shear force? If there is no load between 2 points, let's say this is A and B, let's imagine there is no load between 2 points, then the shear force will not change. Then shear force does not change. So what is the diagram then? Shear force is horizontal. So if you remove this load, we can see a horizontal reaction. So diagram. So this will be the shear force diagram if there is no load between 2 points. Let's say this is A and B. This is the baseline. And this is how it looks like, a rectangle shape, right? So you have to remember this, some of the points while you are trying to calculate shear force diagram and bending moment diagram. So we'll see the types of loads. And what are the types of loads? We'll see types of loads. So there are basically 3 types of loads. Let's say A, that is concentrated load or point load. Concentrated or point load, right? So let us try to understand this concentrated or point load. Let us consider a beam. Let's say A, B, it's a span B. When an external load acting on the beam is concentrated at a single point, for example, so one point it is concentrated, the load is acting at a particular point. Those kind of load we call it as point load or concentrated load. It is concentrated at a particular point. So this is the example for or another point load. So let's say this is 50 kilonewton acting on the beam. Let's say 100 kilonewton acting on the beam. So these two are point load, or we can also call it as concentrated load. So now we'll see the second type of load, that is uniformly distributed load. Uniformly distributed load. In general we call it as UDL. So what is UDL stands for? Uniformly distributed load. The name itself says that it is distributing uniformly. So let us consider a beam and apply uniformly distributed load. So we can represent the uniform distributed load by this kind of diagram. So load is, let's say, 100 kilonewton, right? So it is distributing uniformly. In another diagram we can represent with the uniform arrows. So we call it as UDL, right? It is, let's say this 100 kilonewton is distributing uniformly throughout the beam or throughout the span AB. So this kind of loading we call it as uniformly distributed load. So when external load is acting on a beam distributed of the beam over the length, total length, it acting throughout the length L, right? C, uniformly varying load, that is uniformly varying. That means throughout the length the variation will be there, the load will be vary at each point, right? So we call it as UVL. UVL stands for uniformly varying load. Let us take a beam and apply uniformly varying load. Let's say span AB. So it will vary at all the points throughout the length. So this load is nothing but uniformly varying load, right? The load will spread over a beam such a member that rate of loading varies uniformly, right? Every point by point it will vary. So you can call it as like triangle loading, triangle kind of loading, right? And this is a rectangular shaped loading, and here it is triangle kind of loading. So you can see a triangle here, right? And here it is a rectangle. Every point it is a constant loading, it will have a linear loading. Fine. So these are the types of loading. In the next class we are going to see some common shear force and bending moment diagrams for different kinds of loading or different kind of loading conditions.